I got a clap, right? Wait, that's bad. All right. How are we doing on sound? Testing. 1, 2, 3. 1, 2, 3. All right. All right. Yesterday I did predicting reaction outputs. Today I want to go over some examples. Again, just like last time, these are going to be some random examples. I haven't looked at them and I haven't even created them, so I'm going to create them right here, right now for you today. Okay, so if you want a refresher on what we did last time, we first balanced the chemical equation. We remembered to convert everything to moles, and we wanted to do that divide and then multiply, and that's the strategy. So I'm going to just pull just a chemical equation from the internet. We've got pentane, or C5H12, plus oxygen yields carbon dioxide plus water. Let me make sure I'm on the page. Sick. Okay, so we need to balance this, right? Step 1, balance chemical equation. Okay, so we have 12 hydrogens over here, we got 2 over here, so if we multiply it by 6, our hydrogens will be balanced. Similarly, if we put a 5 right here, our carbons will be balanced on both sides. We now have 16 oxygens, so if I'm correct, 2 times 8 is 16. Hey, look at that, we're balanced. All right, so now, just like we need to figure out how much, what do we got here? No, that's too little. 184. Okay, so we're going to start out with 184 grams of pentane, this guy, and we're going to have an excess amount of oxygen, and we want to know how much carbon dioxide we're going to produce. This is actually a pretty interesting question because this is, again, a combustion reaction question, and you know, the world wants to know how much carbon dioxide you're emitting in your combustion reaction because it's like a greenhouse gas or something like that. I don't really know. But anyways, let's figure it out. So we want to know how much carbon dioxide. Step 1, balance chemical equation. Check. Work in units of moles. So right now we have grams, so we need to get this into moles. We need the molar mass of pentane. So grams is going to be on the bottom. We don't know yet because we need to know the molecular mass of this. Carbon is 12. 12 times 5, 60. Plus, so carbon has a molar mass of 12. 12 times 5, 60. Hydrogen's molar mass of 1 times 12 is 12. We add it up. We have 72. Awesome. So let me just erase this. Oh, that's not the best eraser today, huh? Oh well. 72 grams. So we're going to have to do a little bit of division. I had to go find a calculator. So to do this, 184 divided by 72. We have 2.55 moles of pentane. So we're working with just about 2.5 moles of pentane, or let's just do proper rounding, 2.6 moles of pentane. And we want to know how much carbon dioxide we have. So we don't have any coefficient here, but we could imagine a 1 being there. Next step is divide and multiply. So we draw an arrow down from our coefficient, which indicates a divide, 2.6 moles of pentane divided by 1. And then we move over to carbon. And there's a 5. So moving, M, indicates a multiplication. So we're multiplying by 5. So it's just going to be 2.6 times 5. I believe that, yeah. 12.77 moles of CO2. So in some cases you can be done there. If you want to know how many grams of CO2 you have, you need to do one more step of conversion. That's 12.77 moles of carbon dioxide. The molar mass of carbon dioxide is It's going to be 44. 16 times 2 is 32 plus 12 is 44. So 44 grams per mole. Moles will cancel. And our answer is going to be 12.77 times 44. 561.9 grams of carbon dioxide is emitted in this combustion reaction. So let's do another one. So step 1, balance chemical equation. There's two H's over here, so we put a, well, let's actually do zinc. Everything's balanced, so yeah, besides the H's, and then that's going to affect the chlorine, so we're going to have a 2 here. That gives zinc 2, so let me just double check to make sure I didn't do anything silly. I don't want to make a silly mistake here. So zinc 2, hydrogen's 2, chlorine's 2. We are rolling. Good job, guys. All right, so let's figure out how much we're going to start with. All right, we're going to start with 308. Oh, 308 grams of. Let's do hydrochloric acid today. For this one, I don't know why, but 308 grams of HCl. And we want to know how much zinc chloride we're going to produce, because that seems to be more interesting than hydrogen, right? I don't know. 1 mole. We need to do the conversion, we got to find the molar mass. HCl, that's 36, because Cl is 35, hydrogen is 1, so that's 36 grams. Cancels. 308 divided by 36, or just round to 8.6 moles of HCl. Okay, so we go down. There's a 2, so we need to divide by 2, that coefficient. We need to go across, or we're going to move to this one. So times 2. Hey, look, they cancel. That's so cool, because if these coefficients are the same, you're just going to get the same amount of moles of your product. So if you have 8.6 moles of this and the coefficients are the same, you'll have 8.6 moles of zinc chloride. It's called a 1-to-1 ratio. In the past, we've worked with, I don't know, like a 2-to-1 ratio, or worked with a 2-to-10 ratio, or a 1-to-5 ratio. In this case, it's 1-to-1. So however many moles you start with this, you're going to make the same amount of moles with that one. Okay? Oh my gosh. Hey, I got a eraser on the back of this thing. That's so cool. It sucks. Okay. Well, you may be interested in how much mass of zinc chloride do we have. We just have to take it a step further. 8.6, we need to know the molar mass of zinc chloride, which I found out already, 75 grams per mole. Very interesting, isn't it? So just going to do that math really fast, times 75. It looks to be 641.6 grams of zinc chloride, and that is your solution. All right, let's do one more. So step 1, balance chemical equation. I hope you guys understand that this is the product right here. This is the reactant. I didn't have enough room. You wouldn't be able to see it. So hopefully that doesn't confuse anyone. I apologize if it does. We have 3 calciums here, 3 calciums here. Oh gosh, this is going to be a nightmare to balance. I think we are balanced, guys. Yeah, balanced. Step 2, working units of moles. So first off, we need a starting amount. You know what? I'm actually going to say, instead of a starting amount, we're going to go with a production amount. So 301 grams of this molecule. We want to produce 301 grams of that. Yeah, let's pick this one. Let's just pick that one. We could figure out how much we need of both of them, but who wants to do that, right? Not me. Has a molar mass of 20. And we have 3 of them, so that equals times 3 equals 60. Whoa. phosphate, I didn't say potassium, phosphate has a molar mass of 15, and we have 2 of them. All right, now we gotta add these guys up there. I'm not doing that. 128 plus 60 plus 30, 218, I hope. Yeah, 218. 218 grams for every 1 mole of calcium phosphate. Okay, so we need to figure out, dang it, a little bit more calculator work here. Divided by 218. This equals 1.38 moles of that. I'm just going to put of product A. Product A. I erased our water, but we don't need water here, so I apologize for that as well. We have a 1 here, so if we go down, we divide. You probably can't. Okay, we divide by that coefficient. We go over, or we move. So moving to the next coefficient, we multiply by 3. Moving, multiplying, moving, multiply. Okay? And so that's going to be our solution in moles. 1.38 times 3 is going to equal 4.14 moles of this calcium hydroxide solution. So that's how much of this stuff we need. If we wanted to know how much of our hydrogen phosphate, I think that's what it's called, we just multiply by 2. So 1.38, 2.76. So in case you're wondering, you would need 2.76 moles of this guy and 4.14 moles of that. And if you want to know how many grams you need, you can take that one step further like we have done in the past. Just find their molar mass. It's a multiplication step, so it's pretty simple. I hope you enjoyed this video. Let me know in the comments below if there's anything else that I can do for you. Maybe you have some homework questions that you're struggling with. I know finals are coming up for some people, so no one's watching these videos, but if you have anything, you could send it my way and I will do it for you in a video